Welcome to Beekeeping Today podcast, your source for beekeeping news, information, and entertainment. I'm Jeff Ott.
And I'm Kim Flatham.
Hey, Jeff and Kim. Today's sponsor is Global Patties. They're a family-operated business that manufactures protein supplement patties for honeybees. It's a good time to think about honeybee nutrition. Feeding your hives protein supplement patties will ensure that they produce strong and healthy colonies by increasing brood production and overall honey flow. Now is a great time to consider what type of patty is right for your area and your honeybees. Global offers a variety of standard patties as well as custom patties to meet your needs. No matter where you are, Global is ready to serve you out of their manufacturing plants in Airdrie, Alberta, and in Butte, Montana, or from distribution depots across the continent. Visit them today at www.globalpatties.com.
We want to thank Bee Culture Magazine and Global Patties for their continued support of this podcast. Hey, Kim, so you've been pretty busy this last week traveling. What you been up to?
Yeah, I spent a few days in Mississippi with the Mississippi State Beekeepers Association, and the people that were at the meeting were primarily commercial beekeepers. There's some smaller operations there, and they had a day for those, but spent a lot of time with the commercial guys down there and learned a lot about that part of the world and bees and Chinese tallow.
What's Chinese tallow?
Yeah, well, it's an invasive tree that beekeepers love because it makes more honey than you can shake a stick at, and almost everybody else doesn't love because it is an invasive tree.
Kind of like a star thistle in the West.
Yep, exactly right. And there's a lot, but there's a lot of other stuff going on with commercial beekeeping. Mm-hmm. So it was an interesting trip, and I'm going to tell you a lot more about it later.
Oh, good. Well, it's a good time of year for meetings here in the Pacific Northwest, and I'm sure around much of the other parts of the states. We started our rainy season this week. We've had a prolonged sunny October and into November. And now it's starting to rain, and I went out to the hives yesterday, and it's just, I just feel so bad for the bees when they're sitting in there, and it's just doing nothing but raining. And I can see on all my hive sensors, my broodminder hive sensors, that they're still there. The queen's not laying. The temperature in the hive is down. The weight is steady at this point, but it's a sad time of year, so it's a good time to be at meetings.
Yeah, you got to kind of wonder. If I'm a forager who's working my tail off all of the time, suddenly I got a legitimate excuse to stay home and sleep in. I wonder if that's bad,
I don't. Well, some people say busy as a bee kind of counterproductive, but I have to believe there are some lazy bees in the hive. Well, while you were out playing games in Mississippi, Kim, I had the opportunity to speak to Hailey and Nathan of Combplex. They've entered their patented idea into a competition for $1 million and are one of the 18 finalists. The winner will be announced this coming Wednesday, and their approach is novel and innovative. I talked to them last Thursday, and they have a fantastic approach to eliminating Varroa in the hive that does not involve chemicals. I think you'll be excited about this. I sure was. And, let's give it a listen.
All right.
Today we have a team representing one of the 18 finalists in the Empire State Development and Cornell University's Center for Regional Economic Advancement for Grow New York. Grow New York is a food innovation and agricultural technology business challenge focused on enhancing the emerging food, beverage, and agricultural innovation cluster in the central New York, Finger Lakes, and southern tier regions of the state. Today's guest, one of 199 teams competing in the $1 million prize, developed an innovative approach and product called Combplex to fight the beekeeper's number one pest, the Varroa Mite. Thanks, everyone, for joining Beekeeping Today podcast. Before we get into the Combplex, I want to introduce Jenn Smith from Cornell Grow New York to tell us a little bit about the competition. Hi, Jenn.
Hey, how are you doing?
Good. Thanks. Thanks for joining us today. Tell us a little bit about the competition. This sounds pretty exciting.
Sure. Yeah, we launched the Grow New York Food and Ag Startup Competition in May, opening up for applications. We received 199 applications, literally from across the nation and around the world. Food and ag startups ranging from the furthest upstream in the field technologies that help with farming to innovations in getting food and ingredients from here to there safely and efficiently to novel takes on the breakfast in your bowl were encouraged to apply. To be eligible for the competition, startups needed to be in the formative stage, so real businesses poised for substantial growth. After our first round of judging and screening, we landed on a cohort of competitors representing a pretty broad array of points in the food and ag supply chain. The teams were assigned mentors who are experienced entrepreneurs from the region. Again, that's Central New York, the Finger Lakes, and the Southern Tier, who act as connectors between the finalists and the extraordinary resources in our region. And during a 9-week business development phase, teams learned how to be successful in our region's food and ag space. The mentors worked in partnership with each finalist to plan a business development trip to visit the region in October. Of course, some were already based in the region, as is the case with the folks we're going to talk to today. But even in that case, even for folks that are local, there were valuable connections made with people supporting the growth of the industry in our region, researchers, co-packers, manufacturers, farmers. So we're excited to be winding down this inaugural year competition. On November 12th and 13th, we have the live pitches, which will be judged, Shark Tank style in front of a live audience.
No pressure there.
None. There's also going to be great panel conversations and an expo. And this is the first of 3 planned years, and hopefully will be renewed to do this in years 4 and beyond. So we're really excited, and we're very pleased to have Combplex, who are locals, involved in the competition and a member of that finalist cohort.
Wow, that's pretty exciting. And in 199 entries, who went through all those applications?
Yeah, we had a team of 30 people that were involved in reviewing those initial applications and winnowing it down to a more manageable sized cohort. So they're folks, actually, some are from Cornell or from the Grow New York region. Others were kind of national thought leaders or executives that are working in the food and ag space. So a pretty impressive array of expertise.
Great. And I assume not all of them were focused on the beekeeping world. What were some of the other teams, and especially the finalists in the last 18? What kind of product range do they have?
Yeah, as I said, it's a pretty diverse range. And it does go from, the farthest upstream in terms of agricultural work that you can do down to food that would be on your plate, and pretty, a pretty good grouping of points in the supply chain in between that. So, that's true too of the applications that did not end up being part of the cohort. And one of the things that we're really committed to in the Grow New York program is providing specific feedback to people that apply. Oftentimes, the application process can be daunting, and we want people to feel rewarded, even if they're not selected to be part of that finalist group, that they can get some effective feedback. And in particular, we saw a lot of applications that were really great ideas, or startups that were meaningful and had a lot of potential, but maybe just weren't ready for $1 million investment right now. And so that's why it's really promising that we have another couple of years, right? Because the difference between the application that, Nathan, Hailey, you can probably speak to this. The application that you wrote this year, how much further along it would have been than one that you would have written last year this time. That sort of growth curve is pretty steep in, when you're a startup. So we hope to see some of those non-finalists reapply in 2020.
Is there any a prize for making it to the final 18?
Well, 9 weeks of support and mentorship that includes not only the kind of connections to regional resources, but additionally, marketing, publicity, positioning, and pitching advice. All of that is pretty valuable. And then, of course, there are 7 prize winners in all. We have 4 $250,000 prizes. We have 2 $500,000 prizes, and then the $1 million grand prize winner.
Wow.
I'll just say one other thing about the competition that I think is special. Because the resources in the Grow New York region are so formidable, so abundant, we're seeing several of the finalists say, regardless of my status as a winner, I'm going to participate in the Grow New York region with my business. In one case, we have a competitor who is looking to locate his manufacturing here. That's agnostic of whether he wins $1 million or even one of the smaller prizes. So there are a couple of different finalists that have noted that, and that's really our goal, right? To attract businesses to the region. We do want to support these businesses in their growth, but we got to get them here first. Yeah. So we seem to be we seem to have kind of landed on an effective strategy to do that, and it really comes down to those resources that are here in the region.
Nice. And how's it funded? And real briefly.
Yeah. So the New York State Governor Cuomo, one of his programs is the Upstate Revitalization Initiative, and 3 of the New York State regional economic councils kind of agreed to cooperate and fund through Empire State Development this program to be executed by Cornell. So effectively, Central New York, the Finger Lakes, and the Southern Tier got together, said, we will pool our money and give it to Cornell to plan and produce this competition over a 3-year period.
How does one find out about the competition for the next 2 years and possibly further along?
Yeah, great question. So grow-ny.com is our website. The applications for next year open April 1st, 2020, and we'll run those through July 15th. And we're looking at a date of November 17th and 18th, 2020 for the year 2 competition.
I will have that link in the show notes. So if you did not miss it from Jenn right now, just go to our show notes and you can click on the link there and you'll apply right online. Well, thank you, Jenn. So next we have on the podcast from the Combplex team, Hailey Scofield and Nathan Oakes. Welcome to the podcast. Hailey, let's start with you. Tell us a little bit about yourself, your role at Combplex, and how you got interested in honeybees.
Hi. Well, thanks so much for having me on the podcast.
Yeah, you bet.
As a beekeeper and a bee researcher, I consume podcasts at a really alarming rate, and to actually be on one is a personal life goal. So thank you so much.
Oh, wow. Yeah, a dream. I'm glad to be a part of making someone's dream come true and be on a podcast.
Yep, it's happening. So excellent. Nathan and I are co-founders of Combplex, and we actually met here at Cornell. We're both PhD candidates. We met in our first year and started collaborating pretty quickly, and that sort of turned into Combplex over time. But I got started in bees before then, when I was an undergraduate. So I have always really liked insects, and ended up randomly reading Bumblebee Economics by Bern Heinrich one summer, the summer before starting college. Mm-hmm. I'm not quite sure how I made it all the way through that book or found that book in the first place, but I read it and became completely fascinated with bumblebee behavior, foraging, the math and the behavior and evolution behind bee behavior. The next year, I started at Wellesley College and was in a small intro biology course that happened to be taught by Professor Heather Matala, who studies honeybee behavioral ecology. And we had, it was a great class, but we had a really basic assignment. And I forgot to do my homework, which was to prepare a 5-minute presentation about something I loved about biology. It's like the most basic thing ever. And I showed up to class that day completely unprepared, no slides. I couldn't even get a Google image up behind me. So I just thought, what's something I really like that I can talk about? So I stood up in the class and talked about bumblebee foraging dynamics nonstop for 5 minutes. And after that, Heather said, you should probably join the lab. And that was really the beginning of the end for me for any other career outside of honeybees. So I've been working in bee research since then, and came to Cornell to work in honeybee behavior and honeybee health. And that's still definitely what I'm doing every day.
Very good. And I saw on your online bio that you've worked with Dr. Tom Seeley. How did you find that? He's been on our podcast, season 1, episode 19. Yeah. And boy, I could have had him on for the rest. And we could make it the Tom Seeley podcast and just have him on every week.
Definitely.
But he's busy. He didn't have time.
Yes. Yeah. Tom is a really amazing guy. And yeah, I think working with him is really incredible. He's a phenomenal researcher, and he knows more about what bees do than I think just about anybody else in the world. Now I work with Scott McArt. I transitioned partway through my PhD to do a little bit more applied research, and work on some other problems that are sort of more beekeeper focused rather than basic biology of the honeybee. So I'm really thankful that I've been able to sort of cover different sides of the fence and move around. And that's, we're lucky that we can do that here at Cornell because we have so many amazing pollinator researchers that cover all sorts of different areas of expertise. And so in your journey as a student, if you are moving in one direction, you can just sort of easily, move across, what would be dividing lines, but in the community, it doesn't really feel like that at all.
Yeah. And you can move across campus and not necessarily have to go to a different school across country or something.
Exactly.
Just to change
Yep.
areas of focus.
Yep.
That's really good.
Yeah.
Well, Nathan, welcome to the podcast. Tell us a little bit about yourself and also your role.
Oh, hi. Thanks for having us. It's great to be talking with you today. My background in undergrad was electrical engineering. I spent some time working as an EE. For a couple of years, I gravitated more and more towards software and found I liked the smaller startup environments a lot. I joined a cloud computing startup in Seattle. That was fun, but we scaled down, reached the end of our runway. And as that was happening, I was asking myself, what do I want to do next? And I loved the computational biology aspect of what I was doing. And so decided that I would give grad school a shot. And Cornell is a phenomenal area to be doing any kind of biology research. And so in my first year, like Hailey was saying, I bumped into her. And as grad students are often want to do, we found ourselves kind of commiserating about the challenges of our research. And Hailey was talking about the current, now this was 5 years ago, the then current technology available to do just really simple things like monitoring temperature in a colony just wasn't as sophisticated as, say, other disciplines. And so my background in electrical engineering, I thought to myself, I'll just rig something up real quick. We'll have a nice, fun paper, and that'll be that. But then we had the bright idea that amounted to like, hey, wouldn't it be neat if, we commercialize this? This might help us bootstrap a little bit off of our grad student salary. And that put us on this path to where we are today, which has been bouncing around a little bit, the Cornell entrepreneurship ecosystem. And they encouraged us to go out and actually ask beekeepers if what we thought was a solution was actually solving a problem that they had. And many people were pretty interested. They were pretty like, yeah, I'm curious. But mostly we found more and more, everyone was like, yeah, that's fun, maybe. But our real problem are these mites. If you could please just do something about that. And we just kept going back and just being like, well, I mean, I keep hearing that, but we're not chemical people. We can't just invent a new pesticide. And so we were stuck there for a while. in spite of this overwhelming feedback that we were getting. And it just got to the point where we were like, oh, we just really have to do something about this. And so we sat down, brainstormed a bit, and we came up with our current idea. And so, like we were talking about earlier, the maturity of Combplex, say even just a year ago, is night and day difference. We had just finished the I-Corps program, the NSF I-Corps program, which was, they gave us a small bit of funding that we could.
Sorry, that's the National Science Foundation. They have this really great idea that sometimes researchers, we invent something and we're like, oh yes, this is so awesome. This is so useful. Everybody and my grandmother needs a quantum defibrillator, and it's actually an incredibly specific, highly technical tool that maybe like 10 people across the world actually need and have the same problem as you. But, you've just created something new and you're excited about it. So you're like, yes, we can sell this and everybody needs one. But it's much more useful to actually go out and talk to people and actually verify that your invention is solving a problem before you try and commercialize it. So the NSF has set up this really fantastic program. There's essentially like business boot camp combined with some funding to go out and actually meet the people that you think your invention could help solve some of their problems. So one summer we got to do the I-Corps program, the National I-Corps program, and Nate took a couple weeks off over the summer to go meet beekeepers.
Yeah, and so it was actually
there's got to be a story in there somewhere.
Oh gosh, which one do you want? How it sort of progressed for me, that was like honestly one of my favorite summers so far. Actually, I drove around almost 8,000 miles across the U.S., 100% rural areas, and just met the breadth of the personalities that exist in beekeeping, small and large, in the U.S. today. And it was phenomenal. And through that process, we had a really clear bit of evidence that what we were doing, our approach to the remote monitoring, wasn't really solving a big of a problem as we thought it was. And so that's when the Mite idea became more clear in our mind.
So you had an idea, you had the interest in beekeeping, you found that, Hailey, you had a lot of interest in bees. Nathan, you found out that you had an interest in bees, you didn't know it, and now you started to combine the electrical engineering expertise along with the bee biology, and now you're zoning in on, a problem that needed to be solved, and you landed on the Varroa Mite. That's correct?
Yep.
Absolutely. Yep.
It was actually so dramatic when we were talking to beekeepers, and Nate was driving around the Midwest, and I was interviewing mostly smaller or hobby beekeepers in the Northeast because I was still doing research over that same summer. We would have conversations to strategize so that we could try and get beekeepers to talk about their problems besides Varroa mites. Like we ended up talking about Varroa mites so much. And like Nate said, we're not chemical people. We didn't think we could add anything to that, to any possible solutions there. Cause we're just like, no. Let's see if we can, how can we get, this person we want to talk to like move beyond Varroa mites? What are the other problems you have? And there just wasn't, It's such an outsized problem.
It is. It's really bad.
That was when we realized that we were strategizing for that. We realized that we actually just had to take some time and see if there was anything that we could do. Otherwise, what we were working on, remote monitoring, basic electronics in the colony, wasn't doing anything for anybody.
And we've had a couple of those vendors come in and talk about their products, which are really interesting.
Totally.
That's why we got in the first place.
Yeah. And I do enjoy sitting here in my office and checking my
oh my gosh, yes,
broodminder stuff and looking and see what's going on in the hive and saying
definitely.
Well, they're still living.
Yep.
The bear hasn't knocked them over yet or something like that. But that's and I don't have to go out in the yard and find out. Anyways, so you're sitting there and you had suddenly dawned on you the Varroa must be the problem. Let's find an answer. Can you talk a little bit about and remind us some of the biology about the Varroa Mite that you're addressing, and what about the Varroa Mite? Well, just talk about what is the problem and what's known today about the problem with Varroa Mite.
Yeah. So Varroa mites, I kind of describe them as like giant ticks for bees. So they're these parasitic mites that are invasive. They actually originated over in Eastern Asia on the Asian honeybee and migrated across Eurasia and Europe over the last 120 years. And they actually arrived in the United States in the late 80s, this parasitic mite. And beekeepers have been treating their bees for Varroa mites with a number of miticides, chemical pesticides that were really effective. But like a lot of other pest organisms, like you can think of other parasites like bed bugs, they evolve resistance really, really quickly to these chemicals that we use against them. And there's a lot of genetic reasons why they're so good at very fast evolution responding to these chemicals. But the long and short of it is that we've kind of run out of really effective miticides, and it's really difficult to kill a bug on another bug without killing the first bug in the first place. That's a really difficult job. And Varroa mites are particularly bad for bees because they target the bees in a number of different places across their life cycle. So the Varroa mites reproduce in the sealed brood, in the pupae of the bees, feeding on a developing pupae while the mites themselves are reproducing in the cell. So you can have one mite go in and then 4 mites come out at the end of the pupation cycle. So the population in the colony can grow really, really quickly over the season. And then the mites themselves can cause a lot of damage to the pupae, of course, but they also then in their adult stage cause damage to the adult bees by feeding on them and eating the fat body of the bees. So actually, if you have a colony of bees and you pull out a frame and you can see a Varroa mite on the thorax of a bee in there, that might actually be only like 1 or 2% of all the Varroa mites that might be on that frame, because most of them are either in the cells or they're actually embedded on the abdomen. So you have to pick up the bee. You know, if you actually want to see how many bees on a frame have mites, you need to pick them up by the wings and flip them over and see how many mites are actually on the underside. And if anybody's ends up going out beekeeping with me, we'll usually try and find embedded mites. Like Nate stood there for a long time while I'm like, we're going to get one. Hold on. Flipping bees over on the frame. But yeah, so these mites are terrible. And they not only, of course, cause a lot of physical damage to the bees, but they spread viruses that also in their own right cause a ton of damage. And we know that bees are weakened by Varroa mites if they're fed on as adults or as pupae or both if they're super unlucky, and then the viruses on top of everything else. It creates a big problem that then can add to other stressors that bees experience just in the natural state of being bees today. You know, depending on where they're living, you've got forage issues or, you know, other pesticides that they're running into in the course of their foraging, other pathogens or parasites that they might be interacting with. And so Varroa mites are bad for bees.
Yeah. I think every one of our listeners would agree with that statement.
That's good. Yeah, I haven't had a lot of arguments about if Varroa mites are bad or not. It's usually, how bad are they? You know, let's get into the details there. So, yeah.
And there are a lot of different approaches that have been developed for dealing with Varroa mite and Varroa mites, and the chemicals being one. But you know, of course, amitraz was one of the original solutions, and now there's resistance built up against amitraz and other chemicals. Yeah. And so and being the honey and the bee and the food product that the bees deal with in the wax.
Yeah.
Beekeepers are really would prefer not to use the chemicals. So
definitely. Yeah. And something that we hear from beekeepers a lot, and of course, you know, being in honeybee health, a huge thing is you need to monitor, right? If you know how many Varroa mites you have in the colony, in, all the different colonies in your yard, then you can sort of tailor your treatments accordingly and make sure that one colony isn't exceeding your treatment thresholds and potentially threatening the other colonies through drift and spreading of mites between colonies. And of course, in order to know, are your treatments effective, you need to know your mite numbers before and after. But it sounds simple. It's actually a lot of work. To go out, open up the colony, roll the bees in whatever method you want, count those mites, go to the next colony, and then, go out and put your treatments on 2 weeks, come back, roll again or put another treatment if it's a multiple week treatment, whatever you're choosing to do. It adds a lot of chores to your list of things to do. And I think as anybody, even if you're a hobbyist, I don't view monitoring or treating for mites as a fun thing to do with bees. And so we hear a lot, especially from folks who were beekeeping before Varroa mites became a problem. They just want something that brings beekeeping back to the way it was, before you had to worry about mites. Can we just kind of can we just erase them? What can we do where it's not, you got to plan your treatments around, your nectar flows and your honey and brood development and all these different things. It's a lot to think about and a lot to manage. And especially if you are interested in becoming a beekeeper, then that's I think a really daunting thing to have to adapt in your first year and get that learning curve and actually get an understanding of how to keep mites under control. So it's, I think, all around, it's necessary, of course, but monitoring and treating for mites is a part.
So you have the Varroa, you have the technology. So tell me about Combplex.
Right.
What is Combplex? What is it doing for me as a beekeeper? What is it? Let's start with that.
Nate, you want to take this?
Okay, sure, yeah.
It's Nate's brainchild. So
that's definitely not true. So we came up with it together, and like Hailey was saying, it is actually, I don't know if you mentioned this part. It is a really interesting collection of ideas from honeybee behavior, mite biology, and some really basic engineering, actually. So due to the location of mites being primarily in the brood area, we've designed a typical honeybee frame, just like anyone else that you would use. You just drop it inside the brood area, and we have these corridors. And sometimes you'll see on your frames, the honeybees will chew out little holes at the corner of the frame, and they'll use them to get from one side of the frame to the other. We take advantage of this natural behavior that they have. And as they're walking through the corridor that we give them, we can really easily identify if they have a mite. Because as Hailey mentioned, they are big, the size of dinner plates relative to the bees, shiny, red, just, you can pick them out by eye. And so when we notice that a honeybee has a mite, we activate a laser that zaps them. At a tenth of a second, the mite exoskeleton erupts. The honeybee feels it, but she's fine 15 seconds later.
So,
no way.
Yeah. Yep.
So I'm sorry, but I have visions of the Terminator came to mind. You know,
Star Wars,
the glowing red eyes.
Yeah.
And
yeah.
I'll be back. All right, go. So so you're embedding lasers in the frame,
right? So it's a small laser combined with our patented optical detector that allows us to, automate the recognition of, is there a Varroa mite on this bee? Yes or no. And then if yes, it automatically triggers the laser to shoot. And everything's built to bee space. So there's, in our test colonies, we don't get propolising of the whole at all. They cover the outside area with wax, just like we want them to, but they don't seal off the hole at all because, like Nate mentioned, that's sort of a preferred corridor from one side to the other. And as the bees are passing through, if they get zapped, it's a little bit like a sunburn. And because of the anatomical differences in the Varroa mite versus the honeybee, the mites really can't deal with all that heat. And their color also helps. They absorb a lot of the energy of the laser. And then, like Nate said, it kind of just vaporizes the inside, and they like pop. They make a popping noise, actually, when we hit them. It might be the most beautiful sound I've ever heard is when we first lasered a Varroa Mite. It's like a little hissing sound, sort of like a kernel of popcorn. Like right before it pops, it sort of lets this hiss out, and that's the sound of a dying lasered Varroa Mite. It's beautiful.
Yeah, just visions of a secondary byproduct would be Varroa chip or something.
Oh my gosh. Yum, yum.
Awesome. You sprinkle them on a salad and add a little crunch.
Yeah.
Well, so I'm trying to wrap my head around this. And all kidding aside, now this is science fiction.
Sure. Yep.
Very much science fiction.
Yes.
To many of the beekeepers, and maybe the younger beekeepers coming in, and those listening to the podcast. They're like all of us saying, well, this sounds really cool. So is this just one corridor per frame, or are there multiple corridors? Have you figured out a behavioral positioning of these corridors?
Yeah. So right now it's just one corner of one frame, because the whole idea is, instead of having this treatment cycle based approach to Varroa mites, we were thinking, as biologists, okay, what if we can just keep the population suppressed sort of long term? So we start with low Varroa mite levels in the spring before the colony is ramping up, in the early spring. Can we suppress the population and sort of keep it low year round? And in his day job, of course, Nate's actually a population geneticist, a population biologist. So it was easy for us to model the Varroa mite life cycle and see, okay, actually what we need to do is, if starting in, February or March, whenever spring is really happening, can we kill one Varroa mite every other day for the rest of the year? And that's actually enough to keep the population below treatment thresholds year round. And we can do that because it's a slow churn of nurse bees going through the colony. So it's actually targeted to where the Varroa mites are preferentially feeding on those nurse bees, on the younger bees that are taking care of larvae and pupae in the brood nest. And so the Varroa mites are bouncing back and forth in between reproducing in the pupae and feeding on the adult nurse bees, going back and forth. So as those nurse bees are walking around on the comb, when they're going through the corridor from one side to the other, we can start to monitor and zap any mites that are going through. And what this does is cut the sort of boom bust cycle that you can get in populations, and just keep it actually just low continuously. And I think it's really taking advantage of the biology and organization of the bees, and how good the mites are at reproducing and being parasites of the bees, and just seeing, okay, where are the weak points? Where can we actually, in an ideal world, in a science fiction situation, where would we want to target the mites to keep the population low? And that was the question that we asked when we were like, okay, we can kill mites with lasers. Great. Now what? Where can we put this? How can we integrate it into a colony in a way that makes sense for both the bees and the beekeepers and actually works? And so that was kind of our next step from there.
So is it one Combplex? So you put one frame in, or would you put it in all 10 frames or all 8 frames or however many? I assume this is obviously the brood frame. So it'd be a...
Yep. So it's a full frame that you just drop in, and you can leave year round. And so we've engineered it so that we joke it's bee and beekeeper proof. So it's built to last. Like, this is not buy a new one every year. Interestingly, the light bulb that powers the laser eventually does burn out. And so it's like a little cartridge that you can replace. Right now, you get 1,000 zaps. So 1,000 dead mites per cartridge. And then you need a new one, roughly. Yeah. Those numbers will hopefully go up in the future. So it's just, right now, all the models are based on one frame in the brood nest and it's embedded with temperature sensors in the foundation so that you know it's in the brood nest, because if the brood nest shifts over time or in the next year, the bees are making a brood nest in an area that's different from where the frame happens to be located, then you can tell by the temperature difference, because the brood nest is so incredibly temperature stable compared to the other areas of the colony. So you can just move it back to where it should be. And then it's also got some little weight, like pressure sensors, weights on the ears of the frame, so that you can tell if the frame is gaining weight. And again, because of the temperature, you can tell, is it gaining weight because of brood or honey? Because again, those are really temperature different. And a humidity sensor, just because everybody seems to be interested in temperature and humidity. So we've got those on there too. But most importantly, it of course, collects the number of mites that it's seen and the number of mites then that it's lasered. So the laser count, that's the number one thing that we care about, the data coming off of.
And so there's no distinction of it's just worker comb cell size or drone, or it just regular foundation.
It's just regular foundation. Yeah. So the bees can kind of do whatever they want with
whatever
it.
they want.
Yep. And our corner is basically just a little triangle that slips into the corner of the frame and has this little corridor and a bunch of optical sensors in there.
Since it's color based, so does the species of the breed of bee make a difference? Caucasian versus Italian versus Carniolan versus something darker, lighter?
Nope. It doesn't matter what the species of bee is.
As long as it's a Varroa Mite. You can see it. Yeah.
Wow. And I assume it's probably on towards the bottom so that the wings don't interfere with the...
That's right. It's in the bottom corner of the frame.
Okay.
Yeah. Yep.
Wow.
Yeah, right in the middle of where you'd want the brood to be. Well, it's in the corner of the frame, of course, but
Yeah. This is a frame that you can leave in year round?
Yes.
Yep.
Okay.
That was our goal.
And it goes for 100 zaps or 1,000 zaps. Boy, you think in a busy colony that could be a week, maybe? I don't. How long of a calendar time is that usually?
So it definitely depends on the infestation level, and these are all rough numbers of where the device is currently. We're still transitioning from our field trials into a commercial ready device, which is what the Grow New York program is helping us do. And so these are all liable to change. And so we can't, I wouldn't be able to tell you when it's commercially available exactly how many zaps it'll get. And we're continuing to do engineering for that. That's something that we don't love about it, but being able to swap that out makes it cheaper for the consumers instead of just buying a whole new frame. And so that's the current solution that we have.
Yeah.
Right.
Yeah, that's one of the really fantastic things about being a finalist for Grow New York is we had, even though we're located in central New York, we had this opportunity to go out and be introduced to manufacturing groups and engineering firms and distributors under the Grow New York banner. So we're actually transitioning from before we hand built every single prototype. So Nate designed it. And then, I pick up bees as a living. So my hands are pretty good when it comes to small electronics. So then we'd assemble them and solder them all. And then, bee-proof them to the best of our ability, which is the hardest part, I swear.
So that's where you became a soldering expert.
That's right. Yeah, I've been, and we got portable batteries actually, because the bees are so destructive to the electronics. And so for years, I've been carrying around a battery and a soldering iron in the back of my car so that I can go out to the apiary, out to the yard and, pull out whatever frame it is that isn't working and reconnect the wires and, solder it right there with my veil on. And so that's a little bit different than, a nice table setup with a holder and
a workbench.
And yeah.
When do you project it to be commercial ready? Do you have a target time frame?
Yeah. So next fall, so in a year, we have a really great study that doing that's sponsored by the New York Farm Viability Institute. And so they are very generously providing a grant to make 200 of these devices. So that covers all the manufacturing costs. And then we're partnering with the honeybee tech team here in New York State that's also out of Cornell. And so we're going to put our devices, if beekeepers are agreeable, into the same apiaries that the tech team is actually taking samples from. So we can start to map some of this continuous monitoring data onto samples that have been taken from the same bees, from the same yards year after year, and actually have, independent of proving out if a mite zapper works, we can also have this big new glut of data, which we're really excited about. So half of the colonies will have just the detector, and those colonies will be sampled on a regular basis, to ground truth the detector rates and a traditional role, essentially, to look for Varroa mites. So we can start to get a better sense of how to correlate those two very, very different detection methods. And then the other half will have the laser activated. And so we can really compare, within a yard, two different colonies right next to each other. How does this colony perform if we have this low energy sort of continuous suppression of Varroa mites versus another colony that is going to be, treated with whatever Varroa management plan that beekeeper has set up. So we'll actually get that comparison. And we are super excited to be working with beekeepers that range from, they've got 2 colonies in the backyard to folks that have a ton of colonies and are actually moving them for pollination. And then also working with the Wegmans is a big grocery store here in the Northeast, and they have a absolutely beautiful big organic farm in central New York, and they've got about 45 colonies on that farm. And so it's a farm, but it's also really like a bee oasis on the side of this lake. And so we'll also have some devices up there, and we can kind of visit them a little bit more often than some of the bees that might be migrating around the state or across the country, pollinating stuff. And we can start to compare across bees and across beekeepers what are some of the data that we're collecting. And actually that will allow us to further optimize our devices. So we'll start to get really great feedback on, okay, do we actually need 2 corridors, one on either side of the frame, or is one enough? We can start getting those, getting an idea for that. And then that will turn into sort of our V1, our first version that we'll be releasing hopefully next fall in advance for delivery that spring. We are, I think, planning to also, if folks really want to become beta testers, we have a very limited number of these devices that we're going to produce on top of the New York Farm Viability Study. If folks want to purchase one and be involved in the active beta testing, so regularly monitoring their colonies and communicating with us and potentially having some visits. So that is sort of the very first hint of these devices coming out would be this spring for our study.
What is the targeted projected price per frame? Are you looking at pricing? Are we talking hundreds of dollars? Are we talking tens of dollars?
Yeah, so that's another thing that the Grow New York program has been helping us with. So our background is in science and engineering, and this program has sort of helped us learn business as a second language. And so we've been given some really expert guidance from a lot of the mentors and the other business students here. But that is just a long way of saying that we don't know exactly yet. But
because I think we are researchers, we want to be sure that we are selling something that works, that's easy to use, that lasts for a long time. And of course, the pricing in our minds, the value is completely linked to the actual efficacy. And so if we don't have, what we think of as like robust numbers from a big research study, we can't say, okay, so it kills 80% of the mites or 90 or 99%. that all comes down to different values. And then, like we said before, we're just now transitioning from hand building everything ourselves and buying parts like 2 or 3 at a time to scaling up to make 200 and then, a couple thousand. And so there's rough estimates, but the model that we have is that the frame will last for a number of years. So it will be an upfront purchase, and then the cartridges can be replaced as needed. And those are inexpensive and easy to replace.
Yeah. And to answer your question, though, these will be affordable. We're doing this to make a big impact. And so even the most price-sensitive, what do they call them?
Beekeepers?
Even the most price-sensitive, the beekeepers.
So that describes all beekeepers, by the way.
So even the most price-sensitive commercial beekeeper will still find these, within their range.
Or developing nations that may need it.
It's not just the U.S. that have this problem. It's just about every country, with the exception of Australia. They don't have mites yet.
Yeah. Well, and we've had Dr. Sam Ramsey on the show, and he's in Thailand right now with the Tropolalaps mite, and there might be a application of this technology for them.
Yep. So we are also able to kill that. We just use Varroa because it's the most easily recognizable for beekeepers around here.
Well, obviously we don't have any to test.
I was going to say, please don't import any.
No. I wouldn't mind going to test it.
Well, yeah. Well, I know Dr. Ramsey joins us on a regular occasion on the show, and I know he listens, so he may be reaching out to you.
Please do, Dr. Ramsey. We'd love to talk to you.
Yeah. So where can beekeepers find out more about Combplex?
So we will be participating in the Grow New York final pitches, and those are actually going to be live streamed and recorded. So those are Tuesday afternoon on the 12th, and you can find the link by Googling Grow New York. It's pretty easy to find the link on the webpage. Combplex pitches around 3:20 p.m. on Tuesday the 12th. And we are updating our webpage, which was extremely vacant because of IP concerns. And now we've filed all of our patents and feel better about having some of the photos and drawings of the device actually out there. So Combplex, BeeCombplex.com.
I will have all of those links, both for the live streaming on the 12th and also for Combplex in the show notes. So listeners can go and click on those links and find out more from about the product. Last question. If you win that $100 million, wouldn't that be nice? If you win the $1 million, what will you do besides go to Disneyland?
Oh man. So that speeds up our time to market by ballpark 9 months. We'll be able to start paying ourselves a little bit. Right now, it's a lot of ramen and hot dogs.
Yep. So number one, it will allow us to hire ourselves out of we're finishing up our PhDs here at Cornell, which are unrelated for the most part to our commercialization. And we'll be able to actually hire ourselves full time. And so that makes a huge difference because this has just been an afternoon and evenings weekend project. But we'd love to be able to focus on, who doesn't want to zap Varroa mites with lasers professionally? So that's really the dream.
Yeah, I think what you should do is if this doesn't take off, you can just put those little cartridges on a ring or on a glove, and when beekeepers go through their hive, they can just zap mites as they see them.
That's awesome.
Yeah, just get all the bees. Yep, that'd be good.
It'd be like a super glove. I can see a Marvel movie coming out soon.
Yeah.
I really appreciate your spending time with Beekeeping Today podcast and explaining Combplex. It sounds exciting, and as a beekeeper, I am thinking this is going to be fantastic and a great product. They come out. Not only does it draw in all the technology that's available today for the beekeeper in terms of monitoring, but it also provides some proactive work to help the beekeeper manage the hive. So kudos to you both, and boy, the best of luck to you on Tuesday. I'll be watching. I'll be live streaming and hooting and hollering for you.
Fantastic.
Awesome. Thank you so much.
Thanks so much. It was really great to be on the podcast.
All right. Thank you. Wow, Kim. I mean, I will tell you, that just really sparks the geek in me. I think that is such a novel idea and approach to the mite problem. I really want to see it be successful. I really hope they win the $1 million prize, but even outside of that, I think that they have the support in the industry to take it forward.
Well, you gotta commend them for being innovative. It's an idea that I would have never thought of. I gotta wonder though, when that laser kicks on, if Jerry Bromenshank's audio system is going to pick up that pop, and how do you account for that noise or input into his audio system? But you're right. I hope they win something. I hope they're able to take this a step further, because not putting poison in a hive is the best thing we can do.
I agree, and I like the outside the box approach to this solutioning this problem, as opposed to resorting, we have to use chemicals. We have to do something invasive like that. I like using the technology as an approach to solving the problem.
Yep. There's a company that's got a widget out that bees have to crawl through, and it kind of scrapes off, grooms the bees off them. And although it's way different, but there's another way of looking at not putting poison in a hive. So everything that doesn't put poison in a hive is better than anything that does, I think.
Kim, in the last couple of weeks, you've made some news yourself.
Well, I'm stepping down from bee culture, I'm retiring.
You're retiring? All right.
Yep. Down towards the end of November, I'll be out of there full time. I'll be part time for a while. And did I tell you who's going to sit in my office starting then?
Who's going to be sitting in your office then?
Well, probably Jerry Hayes. Jerry Hayes is
well, he was. We interviewed him early on in the podcast.
Yep. History with Dadant as an equipment manager, state inspector in Florida. Worked with Biologics on RNAi, and now he's working with Vita Bee Health. And it's in fact that's that Varroa scraper thing that I was talking about comes from that company. But we're going to get back to him again on Beekeeping Today podcast and see how he's settling in on his new role. So that's it for me for a while. I'm going to take. Well, you and I know we're going to take the podcast series. I think we're going to bump it up a little bit. I get to sleep in and have more time doing this.
Well, good. I think that's congratulations on retiring, and I look forward to working with you more and expanding Beekeeping Today podcast and the other ideas that we have floating around. So it'll starting some fun times now.
I'm looking at this being a good time.
Yeah, I think you should. Well, thanks, Kim. That about wraps it up for this episode of Beekeeping Today podcast. Before we go, I want to encourage our listeners to rate us 5 stars on Apple Podcasts or wherever you download or stream the show. Your vote helps other beekeepers find us quicker. We want to thank this week's sponsor, Global Patties. Check them out at www.globalpatties.com. And while you're there, thank them for sponsoring Beekeeping Today podcast. We appreciate that. We also want to thank Bee Culture Magazine for being our primary sponsor since this all started. Bee Culture, the magazine of American beekeeping. And finally, we want to thank you, the Beekeeping Today podcast listener, for joining us in this show. Feel free to send us comments and questions at beekeepingtodaypodcast.com. We'd love to hear from you. Anything else, Kim?
No, I think that about wraps it up. That was an interesting show. You did a good job with those folks, and I think our listeners got a good window into what's going on there, and thanks for doing that.
Oh, it was fun. They're inspiring, very much so. All right. Thanks a lot.